Hey guys, this is Riya Soni and welcome to the second video of Helm series. Today's video is going to be very important for this series because in this video we will understand the basics of Helm. We will cover topics like what Helm charts and what Helm releases are, how to create your own chart in Helm, and how to deploy it in the Kubernetes cluster. We will be covering all of these today. Additionally, we will learn some very important Helm commands, so make sure to watch the entire video to grasp the important concepts of Helm thoroughly and learn how to apply them in the real world. Because in this video, we will not only understand the concept but also apply them practically. Before we start the video, if you haven't subscribed to this channel yet, I request you to please subscribe and press the bell icon so that you don't miss out on learning DevOps concept and tools in a simple language and with animations. So first, let's talk about Helm charts. To easily understand Helm charts, let's take a small example. Imagine we go to a restaurant and order an aloo tikki burger and some french fries. The restaurant creates an order in our name and notes down our items. Now, let's carefully look at all the steps from preparing the order to serving it. So first of all, to serve this order, the restaurant must have potatoes because without potatoes, they cannot prepare either of these dishes. Having potatoes and ketchup is essential. So let's do one thing. Let's create a dependency column and add these two items to it. Now we have our order and the dependencies needed to prepare these two dishes. But if we look closely at the order, we have an aloo tikki burger and simple french fries. Since there can be multiple varieties of burger and fries, we need to pay attention to the specific variety ordered. Variety means what customization the customer has asked for in these two dishes. So let's create another column and name it customization, where we write aloo tikki and simple french fries. And let's assume the customer likes spicy food. So in the customization column, we write spicy aloo tikki burger. This way, any customization that the customer wants in their dishes, we will write in this column. Considering all these columns, the restaurant will prepare our order, and as soon as our order is ready, they will serve it to us, right? You can relate the same restaurant story to a Helm chart. A Helm chart is like an order in which we specify what objects we want to deploy in Kubernetes. Just like we gave the order in the restaurant to prepare an aloo tikki burger and french fries. And within a Helm chart, we can specify in the dependency section what things must already be deployed in Kubernetes for our application to be deployed. Additionally, with a Helm chart, we can customize our application, meaning if we want to change an image in the object we instructed Kubernetes to create, or update a replica count, or any other parameter, we can do that too. Helm also follows the same pattern of the dependency column, order column, and customization column as in the restaurant example. Here, what we need to create goes into our order column. The dependencies which should already be present go into our dependencies section, and any customization we want to make in our Kubernetes objects are written in a values.yml file. So a Helm chart consists of a collection of dependencies, the Kubernetes objects we need to create, and the values.yml file. Considering all these components, Helm deploys our application in Kubernetes. And just as a order is created in a restaurant, when we deploy this chart in Kubernetes, a release is created. You can directly compare a release to the restaurant order, where after the first order, we can add more dishes and customize them. Similarly, after a release is created, you can make any changes and easily roll back any changes whenever needed. So far, we have understood two important components, Helm chart and Helm release. Before we see how to use these components practically, let's first install Helm on our Kubernetes cluster. For those who don't already have a Kubernetes cluster setup, there is no need to worry or set anything up. Just go to killercoda.com. If you don't have an account there, set one up first. Once your account is ready, you will see many labs available. First, let's go to the playground section. Here, you will find all the empty environments. An empty environment means that certain things are already installed for you. For example, in Kubernetes 1.30 environment, Kubernetes version 1.30 is already installed. You should use this environment. When you enter, you will see on the left hand side a brief overview of this entire environment. And on the right hand side, you will see a terminal. Here, you can see that this is a 2-node Kubernetes cluster, meaning there is one master node and one worker node. The best part is that Helm is also pre-installed here. If you run the command Helm version, you will see that Helm version 3.14.3 is available. So you don't need to set up a Kubernetes cluster or install Helm. You can directly perform all the practical exercises in this playlist within this lab environment. However, keep in mind that the labs we use here are only valid for 1 hour, meaning after 1 hour, this lab will reset and any data you have worked on will be lost. So for those who don't want to set up everything themselves, this is the best option. And if you already have your own Kubernetes cluster, you can install Helm there. To install Helm, you can search Install Helm Kubernetes on Google. You will find Helm's documentation as the first result. There, you can choose any method to install Helm. The simplest way is to use a script by running 3 commands on your system within the cluster, and Helm will be installed completely. Since I already have a Kubernetes cluster and Helm installed on my machine, I will perform all the upcoming practical exercises on my own machine. But today, we will do everything here so that you all can learn how to use it. So we have covered the topic of Helm installation and we have also understood what Helm charts are. Now let's see how to create a chart. To create a Helm chart, we will use the command helm create. And for your chart's name, we will name it My First Chart. And as soon as you run this command, you will see creating my first chart. This means our chart has been created. If you list the files here, you will see a folder named My First Chart. All our files are inside this folder. So let's go inside the folder and understand what files are there and why they are there. You might have noticed an option for an editor above. Clicking on it opens a VS Code window where you will see all the folders of your system. But we need our Helm chart folder. So we will go here and select Open Workspace within the file. And then select the folder that we just created for our Helm chart and click on Open. This will redirect us to a new window where only our chart folder will be visible. Inside this chart folder, we have all the files. You will see a folder named charts, a folder named templates, and also the files chart.yml and values.yml. These are all the files and folders created by our Helm create chart command. These are the files of our Helm chart. Now, let's take a closer look at them and understand their use cases. As we just learned, a Helm chart has 3 important components. One, where we specify all the Kubernetes objects we want to create in the cluster. The second, where we specify any dependencies. And the third, where we specify any customization we want to make, all of which are specified in a values.yml file. So the chart folder you see here, which is currently empty, is the place where you can keep files if you have any dependencies on other charts. The second folder you see is the templates folder, which already contains many files. This is the place where you need to keep the YML files of your Kubernetes object that you want to create. Next, if we look at the chart.yml file, you will find all the information related to the chart. First, you will see the API version, which is v2. Then comes the chart's name and description. Below that, you will find many comments, and underneath, you will see the type, which is set to application here, because types here can be either application or library chart. We don't want to go into detail right now, but you can find their definition in the comments here. After the type, there is a version, which is the version of your chart. And lastly, you will see the version of our application. This information is for reference purposes. So that's our chart.yml file. Now let's look at the values.yml file. As I mentioned earlier, if you want to customize any objects inside your chart or the objects you have instructed Helm to deploy in the Kubernetes, you can write them inside the values.yml file. Think of the things written in this file as variables. We provide values to these variables so that we can customize things. For example, you will see a variable named replica count here. This is so that we can change the replica count of our deployment. Below that, you will also see a variable named image so that we can change the image of our deployment. Helm uses these values when creating the deployment. If you are still having trouble understanding, don't worry. We will now create our own Helm chart, and by doing so, you will understand each file in more detail. By running the Helm create command, we have set up the directory structure. Whether you create your own Helm chart or use someone else, you will definitely see these files. If you want to create your own Helm chart, you will need to follow this directory structure. Now let's move forward and create our own Helm chart. To do this, let's first delete all the present files here. So our templates folder is now completely empty. And we will also remove all the content from the values.yml file. So we have removed everything except the content of chart.yml file. Now let's begin writing our own Helm chart. Today we will create two objects using the Helm chart, a deployment using the Nginx image and a node port service for that deployment. As we have learned so far, we need to keep the YML files of all the collections of objects we want to create in Kubernetes using Helm inside the templates directory. So if we need to create a deployment and service, we need to keep the YML files of both of them inside the template directory. So let's first run the Kubernetes command and generate a YML file for the deployment and service. To generate the YML file for the deployment, we will run the command kubectl create deploy my deployment ---- image equals to nginx ---- dry run equals to client -o yml, and we will redirect the output of this command to deployment.yml file. Same, to generate the service.yml file, we will run the command kubectl create service node port my service ---- tcp equals to 80:80 ---- dry run equals to client -o yml, and we will redirect the output of this command to service.yml file. Now, if you look inside the templates directory, you will see that we have the YML files for both deployment and service. First, let's remove any unwanted fields from these files. In the service.yml file, you will need to make a small change. Here, you need to put the labels of our deployment inside the selector. So we have placed the deployment and service files inside the templates directory so that we can create our deployment and service. Let's leave the values file empty for now and run the helm install command with these files to create our helm chart. To create a chart, you will need to run the helm install command and then provide the name of your release, the name under which you want your chart to be installed. Let's name our release first release for now, and then we will add a dot because all our chart files are present in this directory. If your files are present in a different location, you will need to provide a full path. Running this command will install your chart, and you will see a release created here named first release. You can also verify by running kubectl commands that a deployment and service have been created in your cluster. And by accessing the node port of the service, you can also see the Nginx page confirming that our deployment is working correctly. So installing a Helm chart is that simple. You just need to place the YML files of the Kubernetes objects you want to create with Helm inside the templates directory. Then by running the Helm install command, you can create all those objects with a single command. So far, we have only placed files inside the templates directory and our values file is currently empty. This means we are not passing any values dynamically, and in such cases, if you try to use the same chart to create another release, you will encounter an error stating that you can't create deployments and services with the same name because they are already exist. This is where our values file comes in handy. It allows us to pass some things dynamically and create multiple releases with the same chart. So let's move on our values.yml file and pass some things dynamically for our deployment and service. To dynamically pass fields related to deployment, we will write inside the values.yml file under deployment : and then within that we will pass multiple fields such as name, where we will give the value web server, image, where for now we will keep Nginx, and we will add another field named replica with a value of 2. This clearly shows that we want to dynamically pass the name, image, and replica count within the deployment. Similarly, we will create a block for the service and pass the name as web service. So in this way, we have created 2 blocks for deployment and service and added associated fields to dynamically pass values. It's not necessary to pass values in this way. You can also write things directly such as deployment name, deployment image, deployment replica. You can write it however you find it easier to understand. There are no strict rules and regulations. For now, we will leave the 2 blocks we have created as they are, and we will make changes inside the deployment and service files to fetch values accordingly. To fetch the value for the name field from the values.yml file inside the deployment file, we need to write double curly brackets dot values dot deployment dot name. Here you need to remember that whatever values we want to fetch dynamically, we enclose them within double curly brackets. And if you want to fetch values from the values.yml file, you need to write dot values. where values has a capital V. Then you can directly specify the value you want to fetch by adding a dot. For example, if you want to fetch the name provided inside the deployment block in the values file, we can use .values.deployment.name. This way we have made changes to the dynamically pass the name field, and whatever you write in the values file will be used here. Similarly, we fetch the deployment name within the labels and selector, where we have written my deployment so that the name of the deployment matches with its label and selector dynamically. Similarly, we will dynamically fetch the value for the replica field from the values.yml file by writing double curly bracket .values.deployment.replica. Now let's save the file and move on to the service.yml file. Here we only need to dynamically fetch the name, so we will make changes accordingly. We will fetch the name for both the name field and within the labels field. One more important thing we might be missing here is within the selector field under the service.yml file, where we should dynamically pass the deployment's label. For that, we can pass the deployment name from the values file dynamically. Alright, we have dynamically passed some values in the deployment and service files, and now it's time to apply them and install the chart using the Helm command. You can use the Helm list command to see all the Helm releases you have deployed so far using Helm charts. Here you will also see the first release we deployed earlier using this chart. You can see the chart name, which is my first chart. The release name is first release. It's in the default namespace and its revision number is currently 1. Now let's create a new release using the same chart. And this time we won't encounter the duplicate error because we have changed the deployment and service names and dynamically passed them. So we will run the command helm install again, but this time we will name the Helm release as web release. And we will provide the chart path, which is in this case is a dot. Now if you look at the deployment and service, you will see the deployment named web server and the service named web service. These are the same names we passed in the values file. This way we can dynamically pass many things in the values file and create our Helm chart by updating values from a central place. So today we learned about Helm chart, Helm release, and installed a Helm chart and dynamically passed values into it. To uninstall any deployed Helm release, you can use the command helm uninstalled followed by the release name. This will uninstall your Helm release, and if you check using Helm list or kubectl commands to check deployments and services, you won't find any associated charts or Kubernetes objects. This is because all the objects associated with that chart are deleted using the Helm uninstall command. So that's it for today's video. Today we learned a lot about Helm, and I encourage you to try everything out practically. If you have any doubts, feel free to let us know in the comment section. All the files and the chart from today's video will be available on our GitHub repo, and you will find the link in the description box. If you found this video helpful, please like, share and subscribe to the channel. See you in the next video with more new concepts related to Helm. Thank you.